Hello everyone, this is Team Data Pirates number 17 and today we'll be presenting a solution for problem statement posed for the MLDA DLW Hackathon 2021. Our solution is prediction of cryptocurrency prices using historical and Twitter data. Did you know that Bitcoin increased its value by 1900% in 2017 before plunging below 8,000 US dollars from its high of $19,000 in 2018 crisis? On an average, per day, 100,000 tweets containing the word Bitcoin or any other correlated word are produced. Here are some clippings of the news articles when some normal tweets took control of the entire stock market. That is why market sentiment analysis is an essential part of many trading strategies. Our flow of discussion for this PowerPoint presentation will be as follows. We'll be starting with discussing the problem statement, then moving ahead and talking about the aim of our solution, and then the approach we took towards it. Then we'll be taking a deep dive into the technical exposition and talking about the know-how of what we do. And in the end, we'll be talking about performance metrics and also talk about areas of further exploration. The problem statement posed to us by the organizing committee is as follows. We believe that AI has endless possibilities and it should not be limited to a certain theme. Therefore, the task is to build an AI-based solution that we are passionate about. Our aim, or also can be called the aim of our solution, we aim to analyze the historical data, that is the open, high, low, and close prices of the Bitcoin cryptocurrency, along with real-time sentimental analysis of the tweets centered around the same time to predict the weighted price of the token by the end of the trading market period. Our approach is a four-step process which starts from data scraping from Twitter along with collection of historical data and then passing it to the pre-trained machine learning models to make predictions to predict the closing adjusted prices. Now, we'll be talking about the technical exposition of our solution. We wish to analyze and find if the Twitter sentiments of the public play any role in influencing the market value of cryptocurrency tokens. We have clubbed the first two steps together, that is collection, curation, and processing of the dataset. We propose to involve the Twitter-based Python API called TweetPy for scraping tweets and perform basic data pre-processing with the help of the natural language toolkit, also called the NLTK library, to execute what is called the Vader sentimental analysis upon the same to obtain what is called the compound score of a text. We also suggest involving the AlphaVantage API to retrieve prices for the cryptocurrency in real time. Since scraping data from Twitter and AlphaVantage API for training the model was computationally expensive, we found and utilized datasets from Kaggle. We have taken two datasets available publicly on the Kaggle website. The initial states of the collected datasets were not usable for our model training. There were a lot of unnecessary columns and missing rows in the data frames loaded. We utilized the pandas library under Python for this purpose. For formatting purposes, we had to change the data types of certain columns, mainly those containing dates and timestamps. We aimed to create a clean dataset that consists of columns open, high, low, close, total volume of tweets, compound score, and weighted price. As you can see on the right side, we have finally prepared a clean dataset. In this solution, we have tried out various machine learning models to see which one works the best. So firstly, we'll be starting with linear regression. This is quite like the simple linear equation which we have discussed in earlier classes, but with multiple independent variables contributing to the dependent variable and hence multiple coefficients to determine and complex computation due to the added variables. Random forest. The random forest is an ensemble technique capable of performing both regression and classification tasks with the use of multiple decision trees. The basic idea behind this is to combine multiple decision trees in determining the final output rather than relying on individual decision trees. Support vector machine, also abbreviated as SVM. SVMs are supervised learning models with associated learning algorithms that analyze data for classification and regression analysis. Simply put, it does some extremely complex data transformations, then figures out how to separate the data based on the labels or outputs you have defined. Multi-layer perceptron, also abbreviated as MLP, is a feed-forward artificial neural network that generates a set of outputs from a set of inputs. MLPs are designed to approximate any continuous function and can solve problems that are not linearly separable. The major use case of MLPs are pattern classification, recognition, prediction, and approximation. And the last we have is long short-term memory, also abbreviated as LSTM model. The LSTM is an artificial recurrent neural network, also called RNN. It is an architecture used in the field of deep learning. LSTM is an advanced RNN, a sequential network that allows information to persist. The special property about LSTMs is that they can selectively remember to forget things. Now that we have talked about various machine learning models in the previous slides, let's see how they perform on the dataset we have prepared previously. For performance analysis, we'll be considering two metrics. The root mean squared error, also called the RMSE. It is a good measure of accuracy, but only to compare prediction errors. The lower the RMSE, the better a model given can fit a dataset. The other metric we are considering is called mean absolute error, abbreviated as MAE. It takes the average of absolute errors for a group of predictions and is sometimes considered a better metric, comparison metric than RMSE. As we can observe from the table above, the 0.0 RMSE of random forest and absurdly high value of MAE implies a good probability that the model was overfitting the data. That is, it was learning the details and noise so clearly that it was negatively impacting our model. The small values of RMSE and MAE suggest that multivariate linear regression serves as a better model than multi-layer perceptron, a deep learning model. This is pretty surprising. This may be due to the size of the training data. We can mess around with the hyperparameters within to see what influences the final errors. However, the exceptionally low values of RMSE and MAE from the LSTM make it by far the best model for our discussion undeniably. Due to the time constraints, a lot of intertwined fields were not explored regarding this project. Therefore, we would like to give them a special mention so that in future we can consider them while enhancing this project. This project currently focuses solely on Bitcoin due to its centrality in the cryptocurrency market. However, we can investigate other tokens as well, like the ones on the right, like Ethereum, Dogecoin, and various other tokens out there in the market. The project currently only considers Twitter data for sentimental analysis. However, with the GameStop stock market anomaly, we can assume Reddit is also a reliable source of information regarding the same. Thus, one area of further exploration is involving the Reddit API and even other news channel APIs such as Bloomberg and various others to consider famous discussion forums related to the field of cryptocurrency. Thank you very much for listening patiently.